Hello everyone, this is Dr. Hopkins with more good news. We're still covering buffers. And actually what we need to do is finish learning how to make a buffer. So if you remember last time we chose our buffer and concentration. We used the Henderson-Hasselbalch equation to determine the concentrations that we need of our acid and conjugate base pair. Now we're going to learn how to make a buffer 3 different ways. So let's start with the first one, which is where we're just adding the actual weak acid and conjugate base together. So here's our buffer. We got 100 milliliters of 0.1 molar pH 5 acetate buffer. We've already determined with the Henderson-Hasselbalch equation that acetate must be 0.0645 molar and acetic acid must be 0.0355 molar. Okay, so let's see here. Now, acetic acid is typically a solution in water. And so we're going to assume that we have 1 molar acetic acid on hand. Acetate is typically a solid. In this case, we're going to use a solid in the form of sodium acetate. So it's part of a salt. So what we're going to do is we're going to figure out how many milliliters of 1 molar acetic acid and how many grams of sodium acetate do we need to make this buffer of those concentrations. So here, when we're going to make these 2 concentrations, we're basically just making a solution of 0.0645 molar acetate and 0.0355 molar acetic acid. So we've got 100 milliliters, 0.065 molar. So what we need to do is figure out how many moles of C2H3O2 minus, which is going to come from our grams. So in other words, we need to figure out grams. But I'm going to go ahead and solve for moles. We have 0.0645 molar, so that's moles per liter, times 0.1 liters. And so that would mean we would need 6.45 times 10 to the minus 3 moles of our acetate. So how many grams of sodium C2H3O2 do we need? Now notice that the ratio of sodium to acetate is 1:1. So for every 1 mole of sodium acetate, we get 1 acetate. Okay, so then that would be 6.45 times 10 to the minus 3 moles times the molar mass, which I've calculated to be 18.04 grams per mole. And so then we would need 0.529 grams of sodium acetate. Okay, that's our first part. And then the next part, we need the acetic acid concentration needs to be 0.0355 molar. And we have 1 molar, so this is the dilution problem. So we have 100 milliliters and 0.0355, that's what we want, molar, is equal to 1 molar times whatever volume that would be. And if we multiply that out, we'll find that this should be 3.55 milliliters. So, in order to make this buffer, we would add 0.529 grams of sodium acetate and 3.55 milliliters of 1.0 molar acetic acid, and then we would dilute to 100 milliliters to our final volume. That's how we would make this buffer if we start from both the acetic acid and the acetate. Now let's try again using the second method. So we've got our same stats, our 100 milliliters, 0.1 molar, etc. We've got our concentrations. So we're going to start with acetic acid, and we're going to use our 1 molar acetic acid that we had before, so we'll assume that. And we're going to add strong base to it. Once again, we're going to assume, now strong base, sodium hydroxide, is typically in a solution. So we're going to assume we have 1 molar sodium hydroxide. So in this case, we're going to solve the problem where we have how many milliliters of 1 molar acetic acid and how many milliliters of 1 molar sodium hydroxide do we need to mix together to get our pH 5 buffer. So here we've started the problem because we have acetic acid and sodium hydroxide. And remember, a buffer is a weak acid and its conjugate base. It is not a weak acid and a strong base. So all the moles of our buffer must come from our original volume of acetic acid. So since we want to make a 0.10 molar buffer, we need to make 100 milliliters of 0.10 molar acetic acid. So that's what we're going to start from, and we're going to use the sodium hydroxide to react some of the acetic acid into acetate. All right, so this is once again a dilution problem. So we need 100 milliliters and 0.1, and we have 1 molar. So what volume do we need? We need 10 milliliters of 1.0 molar acetic acid. So that's where we start. So first we'll get our 10 milliliters of 1 molar acetic acid. Now how do we figure out how much sodium hydroxide to add? We're going to do a reaction because here we have a weak acid and we're going to react it with a strong base. And so if you remember, based on the KW, this is an arrow or a stoichiometry problem. But we're going to go ahead and set that up. So we have HC2H3O2 plus OH minus. Remember, sodium is a spectator ion. We don't really care. We're not going to write it. And that's going to generate C2H3O2 minus and water. And they're all aqueous except for the water, which is liquid. And I'm not going to write those parts. Okay, so if we start out, we need to figure out, initially we have 0 of this. We don't care about this. And then we have how many moles of acetic acid. So we have 10 milliliters of 1 molar. So if I do that math correctly, it's 0.010 moles initially. All right, so this is our initial case. What do we need in terms of moles at the end? Well, we need to have, and I'm going to go ahead and move this down. So we want a concentration of HC2H3O2 that is 0.0355 moles. So then moles of acetic acid is simply that 0.0355 moles per liter, and it's going to end up in 0.1 liters because it's 100 milliliter. It's 100 milliliter total volume. So our final moles, then if we did that, this would be 3.55 times 10 to the minus 3. So if we do that math, so we need 3.55 times 10 to the minus 3 moles of acetic acid in 100 milliliters to make 0.0355 molar. Okay, so you see how we're setting this up. We also need 0.0645, and I'm not going to do the actual math itself, but we need this number to be 6.45 times 10 to the minus 3 of acetate at the end, and we need 0 hydroxide, because if we had hydroxide, it would dictate the pH. So how do we do that? So that's actually pretty easy, because 0 to get to 6.45 is plus 6.45 times 10 to the minus 3. And then that means that these are 1 to 1. So this is minus 6.45 times 10 to the minus 3. And that would be minus 6.45 times 10 to the minus 3, right? In order to get this and this. And so we would have had to start with 6.45 times 10 to the minus 3. That's the moles to start. So how do we so our moles of OH minus is equal to 6.45 times 10 to the minus 3. Okay, now we have 1 molar, right? So we need to divide by our moles per liter. So let's see here. We need liters of our hydroxide is equal to 6.45 times 10 to the minus 3 moles divided by 1.0 moles per liter. Right, so my moles will cancel. We'll divide that by 1 liter. We're left with 6.45 times 10 to the minus 3 liters, which is the same thing as 6.45 milliliters. Okay, so we would need to add 6.45 milliliters of 1.0 molar, this is hydroxide, sodium hydroxide. And then we had to add 10 milliliters of 1.0 molar acetic acid from above. And then we dilute to 100 milliliters. And so you can see we have our final product. We have 6.45 milliliters of 1 molar of sodium hydroxide, 10 milliliters of acetic acid, and dilute to 100 milliliters. And based on the stoichiometry, we should be left with the moles that would give us our buffer itself. All right, so let's set up the third method for determining a buffer, or making a buffer, excuse me. And we have our stats, once again, our 100 milliliters, our concentrations. Acetate's once again going to be a solid, a salt, sodium acetate. And strong acids are typically solutions. And so we'll assume that we have 1 molar HCl. We'll use HCl. We could use nitric acid. It doesn't really matter what strong acid we use. So then how many grams of sodium acetate do we need? And how many milliliters of 1 molar HCl would we need to add to that in order to get our buffer in this case? So here we have, starting our third method, number 3 here, we have sodium acetate, solid, and 1 molar HCl. So once again, strong acid, strong base are not part of a buffer. They're used to generate the component of the buffer. So all of the buffer moles, and so I could make this buffer moles, have to come from our sodium acetate, because that's our conjugate base. So we're going to make the weak acid. So we have 100 milliliters, and I've converted to liters. We have the concentration. We want the total buffer concentration to be 0.1, so that means we need 0.010 moles total. And so we would get that from the grams, so it's 0.010, and then if you remember, the molar mass was 82.04 grams per mole. And so our grams initially would be 0.8204 grams. All right, so that is what we need to start with. And then we're going to react with HCl to get our HC2H, or acetic acid. Okay, and so that reaction is going to be C2H3O2 minus plus H3O plus. The Cl is a spectator ion, so we don't really care. It's an arrow, remember, because Kw is large. So we're going to generate HC2H3O2 plus water. Okay, so we're going to follow the same process we did the last time. In this case, we know initially we're going to put 0.010 moles. And we know the final moles of everything we want, because we know what we want is a buffer. We know that, and we did it the last time, so I don't need to redo it. We need that acetate to be 6.45 times 10 to the minus 3, because that's the number of moles that makes it 0.0645 molar. And we need acetic acid to be 3.55 times 10 to the minus 3 after we've done this reaction. And of course we need H3O plus to be 0, otherwise the pH would be very low. So that means that we would have had to have plus 3.55 times 10 to the minus 3. So that means that this is 0, sorry. We knew that to begin with. So that's plus. That means this is minus 3.55 times 10 to the minus 3. This is minus 3.55 times 10 to the minus 3. That means we had to start with 3.55 times 10 to the minus 3. This is the number we're after. We're only doing this stoichiometry to get that number to determine the number of milliliters of HCl. So our milliliters of HCl is then simply 3.55 times 10 to the minus 3 moles divided by 1, because the concentration was 1 molar, 1 mole of HCl per liter. Okay, and then we would, if you want, we'd have to multiply this by, to go ahead. I didn't do this the last time, but I'll do this time. So multiply by 1,000 to get milliliters. And if we do that, we end up with 3.55 milliliters of 1 molar HCl. So along with our 0.8204, so we would add 0.8204 grams of sodium acetate and 3.55 milliliters of 1.0 molar HCl, and we would dilute to 100 milliliters to get our final volume. And then we have buffer. And the last thing we're going to do is kind of go over what we've learned in this video. We've learned that we can make buffers 3 different ways. Okay, we can either add conjugate acid and the acid and the conjugate base together in the appropriate amounts. We can start with all conjugate base, add acid, or start with all acid, weak acid, and add strong base to get to the right concentrations. None of the ways are actually better than the other, and it really depends on what's available. And actually what you're going to find out is that these methods are much easier to do, at least the last 2 methods are much easier to do in the lab than they are in lecture. So until next time.